Okay, class, in this lesson, you're going to learn to calculate volumes of objects such as prisms and cylinders. So let's go ahead and get started. What I'm going to do is, instead of tell you how to do this, I'm going to lead you to figure out what the formulas will ultimately be. Okay. Now, before we do that, we're going to go ahead and start with understanding Cavalieri's principle. And we're going to do that by first identifying or taking a look at these two different stacks of textbooks, okay? So when you take a look at this stack of textbook, which is really a right angle prism, and if you compare that to the oblique prism, okay, what do you notice, or what do you think is the difference between their volumes? If you take a look at these textbooks, you will notice that each of these textbooks contain a certain amount of volume, correct? So if you were to shift these over like this, or actually in any direction, and they're still stacked on top of each other, you will notice that the volume does not change because the number of textbooks remain the same. So in other words, the height remain the same. The area of the textbook, so if we were to lift this textbook up, you'd notice that the areas are all exactly the same. And so what we would notice is that regardless of how these textbooks are shifted, the volume for these two objects are identical. And that's exactly what Cavalieri's principle states. And that is, if two three-dimensional figures, or in this case more than two three-dimensional figures, have the same height, okay? That's the key thing. They have the same height and the same cross-sectional area at every level, then they have the same volume, okay? So in other words, if we go back to this previous example, they have the same area, okay? So we know that these textbooks have the same area, and they have the same height, which these do. This is the same height. And they have the same cross-sectional areas at every level, okay? So we know that the area of the textbooks here is the same. And if we were to take any slices here, take any of these textbooks out, we would notice that the area of that textbook is exactly the same. So when those conditions exist, then the volumes are identical, okay? Now, let's take a look at another example. So if we have this three-dimensional figure, which is a prism, and the area of this prism at the top is B, and we have another three-dimensional figure, and the area at the top is also B, meaning that the areas are equal, and we have another object where the area of this figure up here is also B, and, one last and, the height of all three of these are identical, then we know that the volumes are equal, okay? So they don't have to be the same shape. They could be of different shape as long as the areas are identical and the height are the same. And we know that if we take any slice, any infinite number of slices out from each of these figures and the areas are the same, then they are equal in volume, okay? So that is Cavalieri's principle. Now, let's take this and apply it to the next example, okay? So how would we find a volume of a prism? Find the volume of a prism. So what we have is a stack of paper here, okay? And we don't know how many sheets there are, but there are probably several hundred sheets of paper that make up the stack, okay? If we were to take one sheet of paper, okay, one sheet of paper, and we were to find the area, so it'd be length times width, okay? Length times width. Then we would say that the area is length times width. That's my area. And then my volume, well, actually, before we do that, we're going to say our area is length times width. And we have one sheet, okay, one sheet of paper. We know that this stack is made up of many, 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 many sheets of paper, okay? So let's say that there are 300 sheets of paper, okay? Then what would the volume be? Well, we know that the area here is length times width. And if we multiply that, let's say our volume is going to be length times width, and we multiply that by 300 sheets, then we know that the volume of the stack here is going to be the area times the number of sheets, or 300 sheets, okay? So if we understand that concept and we recognize that every single slice makes up the volume of this figure, then we would say that there are essentially an infinite number, potentially an infinite number of sheets that we could pull out. And the number of sheets make up the height of this figure. And so what this tells us is then that the volume is equal to the area, which is length times width. And now we multiply that by height, and that gives us our volume of this prism, okay? So the key thing here is to identify the area, know what the height is, okay? So how many of these sheets there are, and that gives you the volume. Okay, so now you know the volume of a prism. Let's take a look at how you would apply this understanding to the volume of a cylinder. Okay, so here we have a diagram of a cylinder, and we've got 4 large pieces here. Okay, so we would say that the volume of this would be this first piece times 4 of these, so 1, 2, 3, 4, and that gives us our volume. Now if we apply what we learned with the prism, okay, we could find the area of this circle here, okay, and the area of the circle is pi times the radius squared, okay? So if we were to take one slice of that, that would be my area. And if we took multiple number of slices that make up the height, then my volume of the cylinder is equal to my area, which is pi r squared, times my height. Okay, so it's the area, okay, so we're going to take a slice of this times however many pieces are in here, which is represented by the height of this object. Multiply that by the height, and we get the volume of a cylinder. All right, so hopefully you're starting to understand how volumes are calculated. If you can find the area of a particular object and you multiply it by the height, then you have that volume, okay? So let's take a look at this example. We want to find the volume of this storage rack, okay? And the problem says that Camilla needs to store 20 cubic feet of firewood. And the question here is, will this storage rack be able to hold 20 cubic feet of firewood? Well, to find the volume of this, okay, I drew a triangle over here and copied down the specifics. Okay, the height of this triangle is 5 and the base is 6. Okay, well, the area of this triangle is 1/2 base times height. Okay, now my base is 6, so this is going to be 1/2 times 6, and then the height is 5 feet. Okay, so that comes out to 15 feet squared. Okay, area is in a square unit. So we know the area. Now all we need to do is multiply it by the depth. Okay, here we're told it is 2 feet. My depth is 2 feet. So then my volume is going to be the area times 2 feet, which is my depth. We calculated our area to be 15 feet. So now that's going to be 15 times 2, or that is equal to 30 cubic feet. Okay? So then what we calculated was the amount of wood, or the volume of this storage rack, and we just calculated that the volume is 30 cubic feet. We need 20 cubic feet of firewood, and therefore there is enough space to store 20 cubic feet of firewood. Okay? So the answer is yes. All right. Let's move on to another example. So here we're told that Emily is deciding between the two cylinders shown, and the question is, which cylinder holds more, and what is the volume of the larger cylinder? Okay? I will make a note that the height of both of these objects is 20 centimeters. Okay? Now, the answer to the question, which cylinder holds more, is based on Cavalieri's principle, and that is if the area, if the areas are identical, and we know these are identical because the diameter here is 20 and this diameter is 20, and if we take multiple slices, we're going to have the same 20 centimeter diameter. So those are the same, and the height of both of these objects are the same, and so we know that the volume is identical, okay, based on that principle. So then the next part is, what is the volume of the larger cylinder? Well, it doesn't matter which one we use. Let's go ahead and use the right cylinder. The volume here is going to be the area of the circle, which is going to be pi r squared, okay, times the height, times h. So let's go ahead and plug in those values. Pi times r. The radius here is going to be half the diameter, so that's going to be 10 centimeters. That's going to be squared times, what is the height? 20 centimeters. Okay, and so the volume comes out to 2,000 pi centimeters cubed. Okay, 2,000 pi centimeters cubed. Okay, moving on to another example. So here we're told that Mitchell is repurposing the sandbox, and he's going to repurpose it into a garden. And in order to do that, he needs to buy soil from his school's fundraiser. And the question is, how much soil is needed to fill the sandbox? Okay, so we have the dimensions over here, and it's already written out over here. And so the volume is simply going to be length times width times height, okay, which is 120 times 50 times 8, and that works out to 48,000 inches cubed for the volume. Okay? All right. Hopefully that made sense and that was straightforward. If you were confused or need further clarification, please go back to the beginning of this recording and listen to this again. Thank you.